let's talk about log functions. So for log functions, it's important that you memorize the definition right here. So the log with base b of x is y if and only if b to the y exponent equals to x. So for the current example, you see right here, we want to rewrite as the exponential function. I always start with the base, which is 3, and then you take it to the negative fourth. So that's the exponent. It's going to be 1 over 81. Okay, now for part B, you want to rewrite. So like I said, I always start with the base, 8. And it's going to be 64, and the exponent is 2. Okay, so it's important that you get that memorized. All right, the reason we want to get it memorized, by the way, before we try to solve for the equation, don't forget for ln, the base is going to be, so ln y, the base is going to be e. For log, if you see log by itself, the base is 10. So for number 7 right here, you want to rewrite as the exponential equation. We start with the base, which is e. You raise to the power y equals to 7. For part B, so it's going to be ln, the power is 4 equals to x. Okay, so that's how you rewrite back and forth. Now, the reason we need to know how to rewrite so we can solve the equation. So for example, we want to evaluate. So I'm just gonna put y here. Okay, so what I have is 5 to the y power. 5, the base is 5, is gonna be 1/5. So our goal is to make it the same. So keep in mind that if we have b to the x power equals to b to the y power, if they have the same base and they're equal, the exponents have to be equal. Okay, so my goal is to make it into the same. So you see 1/5, I can change it into 5 as a base to the negative first power. Therefore, y is negative 1. Okay, so same thing. I'm just going to put a y there. 2 to the y power equals 32. So my job is to make 32 into some number with base 2 and the exponent is 5. Therefore, y is 5. Number 9, I'm going to do the exact same thing. So I take the base, I raise to the power equals x. So this is just purely solving, right? So that's 1 over 7 squared, which is 1 over 49. So that's x. Okay. All right, now let's take a look at the domain. The domain of the log function, which is this part right here, the domain. So what I have, I'm gonna go ahead and rewrite for you. So x right there have to be positive. Okay, we cannot have a negative number because you think about this. You take b to the y power, you can never get a negative number here. So that's why we always have x be positive. Okay, whatever in there is going to be positive. For our current problem, you see if we take a look at the numerator, it's always 5. So there's no way it's going to be a negative number. The problem is the bottom. So the bottom, you have to set it to be positive. So x is going to be greater than 6. So for the domain, it's going to be from 6 to infinity. Make sure you don't include 6, because if you include 6, you get 0. For number 11, they pretty much want to test for the properties if you know it really well. And there are three properties you need to memorize. They are very similar to the rules of exponents. So you see right here, if we have the products, it's turned into addition. If we have division, it turns into subtraction. If you have the power, you can bring it to the front. So what we have right here for part A, you see part A, we have addition, so we simply multiply the two numbers, 5 times 7, which is 35. So the answer is going to be log with base 9 of 35. For part B, you have A on top and 3 on the bottom. You have 3 here, so this number has to be 8. For part C, you see that we have the power to the front, so we bring it for the base is the base is 6 of 3, and you raise it to the fourth power. So if you simplify it, we get 81. Okay, so those are the three properties you need to know really well. Now, based on those three properties, we can expand a log function. So you can see right here we have division. So I have x minus log z to the ninth power. You don't want to leave the power, so I have to rewrite one more time and bring 9 to the front. I understand that you can definitely do it in one step. Okay, so you see right here what I have is the cube root, so we should definitely rewrite the problem before we expand the expression. So I'm gonna, instead of writing cube root, I'm just gonna write to the 1/3 power. Okay, so what I have is 1/3. You bring it to the front. What I have inside is x to the 5th power, so 5 to the front, plus log z because it's multiplication, and then we have divide, so I have minus log y, and then we bring 2 to the front, and that's gonna be my final answer. Now you can definitely multiply it, so you can rewrite and do 5/3 log of x plus 1/3 log z minus 2/3 log y if you don't want to use the parenthesis. Okay, so same thing over here. You have to be very careful with this one. So once again, I'm just going to rewrite and put it to the power of 1/3. Okay. So what I have is 1/3. You have to be careful here. So you see that we have the addition. You can't break it. Okay, it has nothing to do with the property. So I bring it to the front. What we have is the division, so I'm going to subtract. And I have 5 to the front. Okay. So let's keep it that way. Like I said, if you want to multiply, you can do this. Log x. Okay. A lot of people try to break this. Not right. Okay, so keep it like that. Okay, now we do the opposite. We want to make it into one single log. So you should see only one log, right? So I should see only one log. So what I have for W, I have the 1/5 power. And then addition, so that's multiplication. And I have 3 in front, so that's Q. Division, Y. Okay? So if you want to put the radical for 1/5, that's fine too. Let's try to solve the log equations. So what I have right here, you will see that sometimes we have two types, type A and type B. So type A is you probably see log and then you have maybe another log, but then somewhere in there you have a constant. Type B is you see log everywhere. You don't see a constant. Okay, so for example, number 18, you see that we have a constant. So that's type A. So how do we deal with type A? First you want to make sure that we have only one single log. So make sure we have one single log. In this case, we do. Okay. Now I'm going to use the definition. So use the definition. And the definition is 4 square equals to negative 2x plus 11. Now we ended up with a linear equation, so you can just solve for x. So I have 16 here, negative 2x plus 11. Subtract 11 on both sides, I ended up with 5. Negative 2x, x equals to 5 over negative 2. So notice for log equation, make sure that when you plug it back in the original, you are not allowed to have a negative number for the domain, just like we mentioned earlier. Okay, so for number 19. Number 19, we have a single log. So we have a single log just like number 18, but we need to isolate the log. You have that negative 4. So instead of having that one, I'm just going to divide. So now I have log 2, 5x equals to 3. Now I can use the definition. So I have 2 cubed equals 5x. So that's 8 equals 5x. So x equals to 8 divided by 5. Okay, once again, make sure you check your solution so we don't have a negative back in here. All right, moving on to number 19. Number 19, you see that we don't have like I said, we have to isolate log. So for number 19, we divide to get rid of negative 4. For number 20, we subtract 3 to get rid of 3. So I'm going to minus 3 here. So I ended up with ln x plus 5 equals to 5. Okay. Now, for this one right here, because of ln, you can definitely apply e to both sides to get rid of it, to get rid of ln. So if I apply e here, I apply e here, I ended up with x plus 5 equals to e to the 5th power. So x equals to e to the 5th power minus 5. And you can use a calculator for this. Okay. All right, number 21. So you can see that 21 right here, we have log on both sides, and then we have a constant somewhere in there. Okay, so these are the steps. This is definitely type A, but this is the step for us to do. So first, move logs to one side. and then you make it into one single log. And then we use the definition, and then we just solve for x. Okay, so first I'm going to move log to one side. So I have log 2x plus 3 plus log base 2 x plus 5 equals 3. So now how do I combine to one single log? You see addition, so we have product rule. And then I use the definition, so 2 is the base, third power equals to x plus 3, x plus 5. Now you see we have parentheses, so I'm gonna try to get rid of it. So I have x squared plus 8x plus 15. Now you can see that we have quadratic. So in order for us to solve for quadratic, we need standard form. So I'm gonna try to make it into standard form. Okay, and then from here I can just factor. That would be the easiest way. So I ended up with x equals to -7 or x equals to -1. But watch, if I put -7 into the original, I'm going to end up with a negative number right here, a -4. So we have to cross out -7. Okay, so we only keep -1 because if you plug in -1, we still get a positive. So we're okay. So it's very important that you do this because we only have one solution for this problem. 22. So you see that we have ln everywhere, right? So this is type B. Now for type B, once again, because you have log everywhere, so you don't have to move log to one side because you have log everywhere. So all you need to do, step 1, is combine it into one single log. And then when you have one single log, you have log of something equals to log of something, and they have the same base, you can just drop the log. And then 3, you solve for x. Okay, so you can see it right here. If I want to turn it into one single log, I will get ln x plus 8 over 2 ln x. So you see ln of something equals ln of something. You can simply drop ln and make it into that. And from here, we just solve it. X plus 8 equals to 2x. So 8 equals to x. Okay, so the reason type B is so easy because we have this property. If we have the same base, then the argument have to be the same.